Now that we have a linear equation, go ahead and pause the video and solve as usual. How did it go? You may have followed a different solution path, but here is one way we can solve this. First, we use the distributive property to get 2x plus 2/3 equals 4x minus 4. Now, let's subtract 2x from both sides of the equation. This gives us 2/3 equals 2x minus 4. Now, let's add 4 to each side of the equation to get 14/3 equals 2x. We're almost there. Now we need to multiply each side of the equation by the reciprocal of 2, which is 1/2, to get 7/3 equals x. Let's take a look at example 3. The question is, can we determine if there is a solution to this equation? Yes, we can determine if there is a solution to the equation because we can multiply each numerator with the other fraction's denominator and then use the distributive property to begin solving it. Go ahead and pause this video to give it a try. How did it go? Let's check. Remember, we may have solved it in different ways, and that is okay, as long as our final solutions are the same. The first thing is to cross multiply to create the equation 8 multiplied by the quantity 6 plus x equals 3 multiplied by the quantity 7x plus 2/3. Using the distributive property, we see that 48 plus 8x equals 21x plus 2. Next, we need to subtract 8x from each side of the equation to get 48 equals 13x plus 2. Now we need to subtract 2 from each side of the equation to find that 46 equals 13x. We can multiply each side of the equation by the reciprocal of 13, 1/13, to find 46/13 equals x. You may be thinking that we are leaving these fractions unfinished, but since the directions don't tell us what form to leave our answer in, we can leave 46/13. This is acceptable. So let's take a look at one more. Let's use our understanding of proportions to solve linear equations that at first glance did not look like linear equations. We learned that we can multiply a fraction with more than one term in the numerator or denominator, and that when we do, we should put these expressions in parentheses so that we do not overlook the need to apply the distributive property.